a particle moves from rest and moves with constant acceleration. If the particle travels 39 meters in the 7th second, so t is equal to 7 here, the 7th second, find the distance traveled in the 10th second. And it moves from rest, and this is the 2015 question. So let's just jot something down, a little diagram. Let's say this is when t is equal to 7, and this one is t is equal to 6. The distance traveled in this little section is the distance traveled at 7 seconds minus the distance traveled for 6 seconds. So we use this formula, s is equal to ut plus a half at squared. We should be able to simplify down. What do we not know? We don't know a. So let's have a look at s in the first 7 seconds. Starts from rest, t is equal to 7, plus a half times a times 7 squared. So the distance traveled in 7 seconds in terms of a is 49 over 2, which is 24.5 a. So let's see what it is in 6 seconds. It's going to be again 0 times 6 plus a half times a times 6 squared, which is 36 divided by 2, so that's 18a. So the distance traveled in 6 seconds is 18a in terms of a. So after 7 seconds, or the interval in here, the 7th second, s7 minus s6 is 24.58 minus 18a, which is equal to 6.58. And they tell us the particle travels this 39 meters, so this will help me get the acceleration. So we can see that 6.58 is equal to 39, which would make a 6 and a half, 6 sixes are 36, 6 meters per second squared. So that's the acceleration. So if we want to get the distance traveled in the 10th second, it's the same diagram. Here's the interval between 9 and 10. So we want to get the distance traveled after 10 seconds and take away the distance traveled after 9 seconds. That will give us the 10 second. So S10 is equal to, again, it starts from rest plus a half times a, which was 6 times 10 squared. So that's 100 times 6, 600 divided by 2, 300 meters. That's S10. S9, 0 times 9 plus a half times 6 times 9 squared. So that's 3 by 81 is 243. So S10 minus S9 is 300 minus 243, which is equal to 57 meters. A nice question dealing with time and distance.